Again, in case you joined in the last couple minutes, my name is William George. I'm one of the hardware analysts here in our labs department at Puget Systems. And my sort of specialization in testing has been photogrammetry, so Pix4D and others, along with 3D design and animation, rendering, engineering applications, some VR stuff, kind of a big mixed bag of different applications that I spend time testing. But today we're going to be focusing specifically on Pix4D. So what we're going to try and cover today, an introduction, a little bit about what we're doing, and then slides aren't moving here. There we go. We want to kind of cover a little bit about us as a company, and then the sort of an overview of the main hardware in a modern computer, how those components are utilized by Pix4D and how they affect processing speed, and then some specific hardware recommendations, along with a few things to avoid that'll hopefully help you out when you're configuring a workstation, and then kind of a way to approach how to spend your budget to get the best performance. Most of this is going to be very general information about Pix4D and PC hardware, but if you're actually in the market for a workstation, we highly recommend talking with one of our technology consultants. It's free. They're here and available via phone and email. And we're happy to help. We do a lot of internal training, so all of our tech consultants are up to date on things like Pix4D performance and other applications you might be using. And we can definitely help you out with stuff tailored to your specific budget, your needs, the combination of applications you're using. And please ask questions. There should be a Q&A at the end of this. I'm not exactly sure how it looks from your end. I'm used to doing it from the presenter end, not the observer, but there's going to be some time set aside at the end to answer questions. If you have any, I'll do my best there. And then we've also got discussion sections at the end of each of our articles on our website, which I'll show you how to get to that in a little bit here. So if you have questions later on or want to go look at some of our articles and then ask questions based on that information, you're absolutely welcome to. We encourage that interactivity. In fact, there's what the little section should look like for how to ask a question if you want it answered in our FAQ at the end here. And just a little bit of background about us here at Puget Systems. We've been around for, I believe, 19 years now. I've been here for 14 or 15 myself. And we specialize in building custom high-performance workstations for professional applications like Pix4D and many others. And our emphasis is also on making it a very personal experience, making sure that you get the system that's right for you, not just some off-the-shelf big box sort of thing. And we also focus heavily on support, making sure that we're providing you with assistance after the fact if you're having any trouble with the system, making sure it's working smoothly, things like that. We do lifetime tech support included with all of our computers. We also are partners with a lot of the different hardware companies out there that are actually building the components we use, Intel, AMD, Samsung, and NVIDIA. And then we try and work closely along with the software vendors as well, like the folks that make Pix4D and Adobe and others, so that we have sort of both the hardware and software sides covered and can help you with that. I guess that's probably sufficient. We'll jump right in here. Sorry, let me adjust a little bit. There we go. As I mentioned before, we've also got a lot of articles on our website that you might find interesting later on. And we also have system recommendations. So everything that I go over here today, if you wanted to actually go purchase a system like that, you could do so on our website. You could also take the information and go build a system on your own or buy one from another vendor if you prefer. But if you go to our website and you go up to the solutions section, you can just drop down to photogrammetry, and the systems we recommend for Pix4D are going to be right there. And then we've also got publications. So if you just want to look at the data and not interested in a system right now, go to the publications section and then down to articles, and you can sort by specific software package like Pix4D in this case, or by CPU or video card, whatever it is that you're interested in learning about. So without further ado, let's jump into what PC components do and how it affects you, or more specifically in this case, your Pix4D performance. I know this is going to be fairly general at first, so please bear with me if you're already technically savvy and some of this is stuff that you're already familiar with. But we're going to start with the basics. The CPU, or central processing unit, is kind of the main component that does calculations inside a computer. Just about everything that you do with a computer interacts with the CPU in one way or another. There's two primary characteristics that most people are aware of about the CPU. It's how many cores it has. You'll hear things like quad core or 8 core, things like that thrown around. And then it's clock speed, which is usually given in gigahertz. The core count is how many individual things the CPU can be working on at the same time, basically how many different code things can be running. And then the clock speed is how much each of those cores can do per second. It's individual calculation steps per second, basically gigahertz. Um, and there's some complexity to it. A lot of calculations take many of those individual little steps. It's not like it can do a massive multiplication in one step. There's multiple things that have to go on, but it's basically an indication of sort of how wide the CPU is, how many cores, how much stuff can be going on at once, and then how quickly the stuff moves. You kind of want to think of it like a car analogy, like a highway, how wide the lanes are, and then how fast the cars are moving on it. But because there's different manufacturers, Intel and AMD and others, and there's also different generations of CPUs and different architectures, you really can't use just those two data points to compare things unless you're looking very specifically within one family and one generation. There, it can make sense to compare core count and clock speed, but beyond that, what you really need to do, and what we do a lot of here at Puget Systems, is actually testing the software that you want to run on different hardware configurations and measuring how it performs. So with that in mind, let's look at what Pix4D does with the CPU. It uses the CPU very heavily, but in different ways depending on which step. Hopefully you guys are familiar with this. There's kind of 3 general steps in Pix4D. Step 1, initial processing, is mostly single-threaded. So high clock speed is good. And the charts that I've got here, to keep it easy to read, I've kept the ordering of the CPUs the same in every chart that we're going to go through here. But it's basically ranked from most expensive at the top to least expensive at the bottom of the CPUs I included. And you can see lower's better. So actually the cheapest CPU here, this Intel 9900K, is the fastest one in step 1, where all that matters really is single-threaded performance. The number of cores aren't helping. But you move on to step 2, that's actually fairly well threaded, and it changes. That suddenly is the slowest processor in step 2. And processors with more cores, like the AMD Threadrippers listed there toward the top in red, do tremendously better. And then step 3, which, by the way, again, probably familiar with this, but step 3 only occurs in maps. So I know that's what most folks are doing in Pix4D, but if you are doing modeling, you don't really have to worry about step 3. Model processing only does steps 1 and 2. But if you're doing maps, step 3, that's actually the most well-threaded. So it's using the cores to the best effect out of all those steps in Pix4D. And there you can see that, again, the high core count processors actually do really well. And this is the only step where the crazy high-end dual Xeon that I tested with 2 28-core CPUs there actually ended up being the fastest. But if you go back in the other steps, it's substantially slower, which means that in the end, when you look at the total processing time, which really is what matters, great if your CPU is faster in one step or another, but if it's slower everywhere else, you're going to end up with slow processing times in total. What we see here is that actually the most recent AMD processors, their Threadripper chips and the higher end of their Ryzen series, are fantastic processors. And so we're going to get into more specific recommendations toward the end. But you can see there they've done a really good job in recent releases with combining both high clock speed and high core count. And that's sort of the holy grail, is combining both of those, which those processors do, and that really benefits Pix4D's overall performance. And to kind of give a second point to illustrate this, I actually just got done doing some testing for a specific user who had a project that he was running on a dual Xeon system, granted a few years old. I think it's about a 6-year-old processor, a pair of processors that it's running on, but it was taking 28 hours. This switches from seconds that I was using before on the measurements to hours. I thought that'd be a little easier to read here. And it's a specifically much more complex data set than what we have. It's about twice as many images as our biggest data set and higher resolution, almost 2,040 megapixel images. And it was taking 28 hours on his dual 10-core Xeon system. And you can see there on AMD's new 24-core, I didn't have the 32 available to test this week, unfortunately, dropped it down to just over 11 hours. So tremendous improvement that modern processors offer over stuff that's even just a few years old. And you can also see AMD's Ryzen did very well there too if you're on a little bit more of a budget. Those are great processor options. But you can see that the impact of having a CPU that's both high core count and high clock speed is really what Pix4D wants. And again, some specific implications there, models, or if you have specific projects where step one is for some reason an abnormally large % of the overall processing time, those will tend to do better on things that are just high clock speed without so much core count. Maps, again, with that additional third step, will skew more towards benefiting from high core count, but clock speed is still important, like we saw with the 28 core Xeons. Tons of cores, but they're kind of slow per core, ends up not being fast overall compared to much less expensive processors. Moving on to the video card, or GPU, which stands for graphics processing unit. That's the chip specifically on the video card that handles calculations related to what is being displayed on the screen. So these processors are designed to update millions of pixels dozens of times a second, meaning that their hardware is designed for lots of little tasks very quickly, all at the same time. And they've also got dedicated memory on video cards nowadays. You'll hear, in addition to the model number of a video card, usually they'll say 4 gig or 8 gig or 12, however many gigabytes of memory it has. And something to note here specifically that's applicable to Pix4D is that in recent years, a lot of work has been done, especially by NVIDIA, to allow other types of calculations to be done on the GPU as well. And that's what Pix4D does with it, actually. It specifically uses the GPU to help speed up processing during step one. And the GPU is utilized here, but again, CPU selection actually still has a bigger impact. And it's also worth noting that only one GPU is beneficial. We tested a little bit, and granted it's a few months old now, but in our testing, we found that multiple video cards actually slowed things down very slightly. So you don't need to invest in like a 4 video card system or anything like that, which some other software packages might like, but Pix4D doesn't need. And we also saw that once you had a mid-range video card, really didn't matter. Oops, I went ahead of myself there, sorry. It didn't really matter having a much higher end one. As you can see in the chart there, it's only a matter of a handful of seconds between a lot of the different video cards. So you don't need to invest a ton of money there. You just want to have a decent card. And then it is worth noting, though, that video card performance also affects viewing the 3D model that's generated at the end. So if you do a lot of manipulating of that model afterward, looking at it, cutting things off the edges, adjusting things, or in the point cloud stage, at that point, if you like to look around, that's affected by the video card as well. So if you have really complex projects, make sure you get something a little on the more powerful side, and especially with a decent amount of video memory. Moving on then to RAM, which stands for random access memory. That's the short-term storage on a computer. It's where all the data that's related to the operating system and open programs and files is stored. It's extremely fast to access, but it's volatile. So when the computer shuts down, everything in the RAM is cleared. Again, I apologize if this is stuff folks already know, just trying to give some basics here. One thing that was worth noting specifically when it comes to applications like Pix4D, which we'll get to in a minute, about how memory intensive it is. If the memory in a computer ends up filling up, the operating system starts to move some of that data off of the RAM and onto one of the local drives for extra storage. That's usually called virtual memory or the page file. There's some different ways to refer to it. But the idea there is to keep the system from crashing so it doesn't just run out of memory and blue screen or something like that. But the downside is that if it does that, the data that gets moved off and stored on the drive is now much, much slower to access, and that can impact performance and make things sluggish or laggy feeling, excuse me. Pix4D is very memory intensive. It needs memory depending on the size of the project, which is affected both by the size of the images you're using, how many megapixels they are, and the number of images you're dealing with. And they can also be affected by quality settings. If you go in and customize instead of just using one of the standard presets like 3D maps or 3D models, you can go in and adjust settings, and some of those will also affect how much memory is used. So to break it down a little further than that, step one actually only has fairly low to moderate memory usage. Again, remember that step is also using the GPU a lot. But when you get to steps 2 and 3, they have very, very high RAM usage. And it's actually kind of interesting. If you want, you can go in and see by a percent how much memory is being used at different steps in processing. After something's done, you can go in and look at the log file that Pix4D generates. and every line will show both a percent of CPU usage, which is total usage across all the cores, as well as percent of the RAM being used. If you want to monitor in real time, you can also do that through Windows Task Manager if you're familiar with doing that. If not, it's very easy. You can find tutorials online for how to look at that. But those will let you look and see. And if you're regularly using 80–90% of your system memory, there's a good chance that it's actually trying to use more, and Windows is already starting to shuffle some of that off into the page file. And then the fourth major topic we're going to talk about here is drives, which are the long-term or permanent storage inside a computer. And there's two main technologies that exist for that. Hard drives, hard disk drives, HDDs, have been around for decades now. It's an older technology using spinning metal disks with magnetic storage, and nowadays it's very cheap and very high capacity. You can get ones in excess of 10 terabytes, but it's slow. You've got a spinning metal disk there, and it literally has to wait till the disk spins around to the proper place and move a reading or writing head along the disk to get to the data. So especially if there's a lot of little random reads and writes going on, like what would happen if you ended up spilling over memory and needing to use a page file, tremendously slow. And because it has moving parts, eventually they will all mechanically wear out. It lasts years usually with a good quality hard drive, but that will eventually happen. The newer tech is SSDs, or solid state drives. It's the same sort of stuff that's used in flash memory and cameras and phones and things like that, just scaled up. And it is much, much faster. The main downside is that there's a limit to the number of times each section of memory can be written to, which I realize I wrote there twice. Oops. And it sounds bad at first, but they're actually, the firmware on the chips, or excuse me, on the drives is smart enough to keep track of all that and avoid using the same piece of memory over and over. It'll spread those writes out across the drive. So what you'll find with solid state drives is usually there's a rating that they have for how much total data can be written to the drive. And it's often up in the hundreds of terabytes, sometimes petabytes. So unless you're going to be doing a tremendous amount of writing to the drive, you're probably never going to reach that. And even if you did and had to replace the drives periodically, the speed that they offer is far, far beyond anything a hard drive has. And again, especially when you hit situations like the system needing to use the drive as a page file, it's still slower than RAM, but it is far, far faster than a hard drive. It'll also affect things like Windows boot times, stuff like that, how fast applications load. There's a lot that is affected by the drive speed. In addition to speed, there's also the question of capacity. This is actually something I ran into by accident when I was working on that project that I mentioned earlier, testing for a customer. Pix4D needs a lot of disk space beyond just the amount that the images themselves take up. It's generating a lot of data during processing. And in particular, step 3, if there's not enough data available, will simply fail. I ran into that a couple times before I finally freed up enough memory to process that on one of the test systems. So you want to make sure you've got plenty of available space on the drive that you are storing your project on. And again, to go over kind of what drive speed impacts, it's how quickly Windows boots and Pix4D itself starts. It'll also impact how long projects take to load up and to save. And then again, as I mentioned earlier, performance if there's not sufficient RAM. Bottom line is really there's no reason not to use solid state drives. They are a little more expensive, but you can get large enough ones without spending too much money. The only place I would use hard drives anymore is as a secondary storage drive for holding old image sets, finished projects, that sort of thing, stuff you just want to have around but aren't going to be actively working on, or for backups, which is important, and we'll talk a little bit about that again later on. And so with that kind of overview of those main 4 categories done, we're going to dip back into each of those categories with specific recommendations. So on the CPU, kind of a general rule, like I mentioned, you want to get the best balance of core count and clock speed that you can. For a specific recommendation, as of right now, I would go with the AMD Ryzen 3950X for most folks. It's a fairly affordable processor, but it's fantastic performance. 16 cores, very high clock speed. If you wanted to move up from there, something to consider would be going up to AMD's Threadripper 3960 or 3970. Those are several $100s more expensive. Just ballpark, the 3950 is about $750. The 3960 is around $1,300, and the 3970 is around $2,000. So it definitely goes up And they're not a lot faster, but if you want the best processing times, shave off an extra hour or two on some really big projects, they will do the trick. The other thing to note about the CPUs is they will affect, between the CPU and also the motherboard, how much RAM a system can have. The 3950 goes up to 128 gigs of RAM. The Threadripper chips will go up to 256. So if you're working with really large projects and think you want that extra RAM, that's another reason to go up to Threadripper. Something to avoid, dual CPU systems. Most of these tend to have lower clock speed. They can cram a lot of cores in. Like in that earlier chart, if you remember, there was two 28-core Xeons, but the base clock speed on those is only 2.5 gigahertz, and even the turbo clock speeds were not very high. So despite having a ton of cores and actually doing well in step 3, they did really poorly in steps 1 and 2, and ended up being slower than the much less expensive Threadripper and Ryzen chips. So in general, I would avoid dual CPU systems. They also tend to have other quirks, and I think that's actually part of why the performance in step 2 was bad. You end up with, in dual CPU systems, each CPU controls half the RAM. And so if CPU 1 needs to talk to RAM that's controlled by CPU 2, there's a lot of extra data pathways that memory has to, or the data in that memory has to go through in order to get to the CPU, and that can add delays and other weird things. So I would just avoid those in general unless you have to have it for some other reason. On the GPU, general rule, any mid-range video card or higher should be okay. Specific recommendation right now would be the NVIDIA GeForce RTX 2060 Super, 8 gigabytes. And I apologize, NVIDIA makes kind of crazy long model names these days. But that's NVIDIA's most affordable card that has 8 gigabytes of memory. Anything below that's going to have 6 or 4 or something like that. And it offers really solid performance. If you're familiar with previous models, it's about the same performance as a 2070, which we found to be one of the best performers in Pix4D in the previous generation. If you just want to consider something else, really anything else in the GeForce line will work pretty well outside of the really low-end models. You know, if it's only a $100 video card, maybe avoid that. But once you get up into the mid-range, you're fine. And then I would, in general, avoid the Quadro series from NVIDIA. They're specifically built for professional applications, but they do some weird stuff with their drivers sometimes. And we actually found that with the default driver settings, they actually perform very poorly in Pix4D. If you have to use one for another application, like if you're using an Autodesk application or some other program that really wants a Quadro, just make sure you go visit our website. There's an article we've got about specifically what to do with the settings in order to make sure your Quadro card behaves and performs on par with a GeForce. It's still not going to be faster than a GeForce card, and it will cost you more money. So if you're just doing Pix4D, don't bother. But if you have to have one, there are workarounds to make sure the performance is okay. Then moving on to RAM, general rule is just base it on how much or how big your project files are going to be, both how many images and how many megapixels. And it's kind of hard to nail that down specifically, but as a general recommendation here, what I kind of go with is 32 gigabytes for small projects, which I consider things 500 images or less, 64 gigs for medium, like 500 to 1,000, and then 128 gigs or potentially more if you're working with large maps of over 1,000 images. And again, that's not taking into account the size of the images. If you're working with higher resolution stuff, 40, 50, 60 megapixel, you might want to bump that up a tier. Memory tends to kind of jump because memory modules are only available in powers of 2, basically. So you can't get, like, usually anyway, 92 gigs of RAM or something weird like that. It tends to jump in these 32, 64, 128, 256. It depends a little bit on the specific CPU platform as well, but those are kind of the general numbers you'll see. So you can't really go for something between 128 and 256 usually, for example. You have to kind of step up to the next major number. And then, again, like I was kind of mentioning there, consider if you're using higher resolution images, bump up the memory a little bit to be on the safe side. And if you're not sure how much you're going to need, try aiming for a system where you have room to add more. So for example, if you get a motherboard like a Threadripper with 8 slots for memory, you get a system populated with 4 of those, maybe say 64 or 128 gigs of RAM, but just in 4 slots. And then you've got 4 available slots for the future. So if you start doing projects and realize, oh man, I'm using 99% of my memory, I must be running out, you could add in more memory on your own without having to pull memory sticks out and waste them or buy a whole new system. And then avoid systems with severely limited memory. And this mostly will come down to like off-the-shelf systems at a store, or systems that are very small in size. As the motherboard size goes down in order to fit in a more compact system, one of the things they usually shave off is RAM slots. So you might find something for a nice Core i9 or Ryzen 9 processor on a small motherboard, but it only has 2 memory slots. And so you're never going to be able to go past like 64 gigs of memory. So you want to avoid that, again, unless you really know you don't need the extra memory. And then on drives, a general rule, use solid state drives for the OS, applications, and projects. Again, things beyond that, like storage, you can have hard drives. But for those things where you're actively working, definitely get solid state drives. And our specific recommendation these days would be Samsung's 970 series. They've got a couple different sort of model lines within that, and various different capacities. But we've found Samsung SSDs to be extremely reliable over the years. If you need other brands, Intel drives also tend to do very well. I don't have much experience beyond those 2 series, but in size, I would get at least a terabyte as a good start. That should give you enough space for Windows, applications, and a couple projects at a time. If you have more projects, or if they're larger, feel free to get something bigger there, or you might even consider getting 2 or more drives. We have a lot of customers who will split up and have 1 drive for OS and applications, and that doesn't have to be huge, maybe 500 gigabytes or something, and then have another SSD where they keep all of their projects, and that can be whatever size you need. And you can even have more than 2 drives if you want, depending on the size of system you're working with. And then again, something to avoid, don't forget to regularly back up. Hard drives are fine for that, for just storage or for backup purposes, but you want to make sure that you've always got at minimum 2 copies of your data. I recommend 3, one that you're working on, one inside the system that you're sort of keeping in case something goes wrong with the set you're working on, and then something off computer, off site ideally, or at least an external drive, something not connected. So if your whole system crashed, or if you got a virus or malware, you're not going to lose all your data. Very important. And then some other sort of general system stuff to consider. You want to make sure you get a computer with a good quality power supply and plenty of cooling. Pix4D is going to be seeing their processing often for hours at a time, maybe overnight, maybe for days. And that's going to push the system fairly hard, especially in step 2 and 3 when the CPU is working full tilt. So you need to make sure the system can properly be powered and properly cooled to keep everything going reliably. And you want to also consider what sort of network you're connecting to, whether you're using a Wi-Fi network or a wired network, and especially on the wired side of things, what speed your infrastructure is. If you've got a 10 gig network, you want to make sure you get a 10 gig card in there so you can get the best performance as you're moving files around between stuff on your network. But on the other hand, if you've only got a 1 gig Ethernet network, there's no sense spending hundreds of dollars extra on a 10 gig Ethernet card for that system because you won't be using it. So keep that in mind when you're looking at configurations. And then if you use multiple monitors on the computer, take a look at the potential video cards you're considering and look at the number and type of video outputs they have. Most video cards will support as many as 3 or 4 monitors, but often they'll have a breakdown with only 1 or 2 of each type of video output port. And there's DVI, HDMI, DisplayPort, etc. So you want to make sure, especially if you already got the monitors, that your video card will support the right connections, or if not, make sure you know what adapters you might need and things like that. And then lastly, these days, it's important to get plenty of USB ports. Almost everything that connects to a computer nowadays seems to use USB, mice, keyboards, headphones, speakers even a lot of times. So you want to make sure you get a system that has plenty of those. You can get hubs and things externally, but in my experience, those tend to introduce potential problems, especially unpowered hubs. I would avoid those. But if you can get enough USB ports right on the computer, then you don't even have to worry about it. And then we're going to kind of go back over things one more time, but with this time with kind of a focus on what order to look at components in the system to make sure you get the best value for your money. So what I like to do first is kind of talk about the things to avoid. Avoid off-the-shelf systems. Things you just go down to Best Buy and purchase are usually not going to have the right combination of hardware for good performance in an application like Pix4D. And they tend to also have very limited room to upgrade. So you might go, oh, well, I can add more RAM to the system. You get home and find out all the slots are already used, or worse, sometimes the stuff is soldered on and can't be changed. And another big thing I've seen people run into is underpowered systems. So yeah, there's room to add a dedicated video card, but there's not a big enough power supply, and maybe the power supply is custom to that chassis or something weird. So avoid off-the-shelf systems. I also recommend, unless you're building it yourself, work with a system builder that offers both great hardware and good support. The fastest system in the world isn't going to be any good to you if it's not reliable, if it's always crashing in the middle of your processing. So you want someone or a company with responsive and knowledgeable tech support. Ideally, someone also at least somewhat familiar with the software you're using and the interactions it has with hardware. And that can definitely end up saving you a lot of time and money in the long run. And don't let folks upsell you. Stick with the hardware that you know performs well, either based on this presentation or other benchmarks you can find online from our website or others. Don't just let somebody talk you into something, because a lot of times, like you noted with those dual Xeon systems, that's a lot more expensive. Someone might prefer to sell you that because they'd make more commission, but it's actually not going to give you better performance. And be careful of looking at synthetic benchmarks. Those can be useful in some situations, but there's very few of those that are going to behave exactly the way Pix4D does. So looking at actual real world benchmarks is the best way to go. And then specifically the order I tend to recommend going in is, first, make sure you get enough RAM and SSD capacity. If you don't have enough RAM, the fastest CPU in the world is going to end up being crippled by 16 gigs of RAM when it's processing a big project, for example. So you want to make sure you have enough of that first. Then get a mid-range or higher video card, something that'll support the number of monitors you're using. Again, it doesn't have to be crazy high-end. There's plenty of GeForce cards in the $200, $300, $400 range that would work great. And then once you've got those essentials covered, then max out the CPU within your budget. Again, just because the CPU is more expensive doesn't mean it's worth getting. So look at those charts like we were talking about earlier. Go up to the top end Ryzen you can afford, or if you can go beyond that to the top end Threadripper. One note on the Threadrippers, the ones I was showing earlier are the new 3rd gen ones. The older 2nd gen Threadrippers, and for that matter the 2nd gen Ryzen chips, don't perform nearly as well. So if you're going that direction with AMD, make sure you're getting the new 3rd gen models. And then the information in this webinar is going to be outdated the next time CPUs launch. We just had a bunch, so it should be good for a little while, but sometime next year, both Intel and AMD are going to come out with new stuff, and all this data is going to be old, or the next version of Pix4D comes out and they change how it works, something like that. So whenever you're looking for a new system, look for the latest benchmarks you can find and use that information. We try to keep that up to date pretty well on our website. Every time there's a new version or new hardware releases, we'll update that. And there's other places you can go, the forums and stuff, where you can find people talking about things. And we've actually got a benchmark if you want to kind of do some testing yourself. Go to our website, search for Pix4D benchmark, and you can actually find and download a couple image sets that we use and a little script that will run them and show you how it performs compared to other systems. And if you're looking at sort of considering what CPU to get, one thing I also find helps is don't just look at the cost of the CPU. So like say the 2 Threadripper models, there's the 3960X at $1,300 and there's the 3970X at $2,000. So if you look at that, that's a almost 50% price increase for the higher end model. You're not going to get a 50% increase in Pix4D performance from it. So a lot of people would go, oh, well, that's not worth having. But let's say you're looking at a $5,000 workstation. Now that $700 price increase is only like a 14% increase in price, not a 50% increase. I think I did the math right there. And so that actually might be much more reasonable. If you can save an hour of processing time for only a 14% increase in price, that actually might be worth doing. So consider the cost upgrades or savings in light of the whole system price, not just comparing between the price of the components. Otherwise, you'll get kind of skewed results. So in summary, for Pix4D, the most important single component is the CPU. It needs to have a balance of high clock speed and a good number of cores. Any mid-range video card will be fine. Don't waste your money spending a ton there on a $5,000 video card or something like that. There's no need for Pix4D. Make sure you get plenty of RAM and SSD capacity. Again, base that on how large your projects are, how complex. And if you're not sure what to get or you need help, we're here. Our tech consultants, I used to be one for 9 years. are available. We're not on commission, so we're not going to try and upsell you or anything like that. And if you're looking to get it somewhere else, you can always use the resources on our website, both the hardware recommendations we make and also the specific benchmarks and reviews and things to inform your purchasing decisions wherever you go. You don't have to buy from us. I hope that's been helpful. And again, if you have questions, there's the Q&A button there at the bottom. And our moderator here will be popping up some questions for me momentarily, I think. Let's see here. Okay. How about using the minimum GTX 1060? Will this be enough to use Pix4D Mapper? Yeah, the 1060 should be fine. That, I think, was the lowest end model I tested in my last roundup, and it was a handful of seconds behind some of the others, but that ought to be fine. Again, the main thing there that I would keep in mind, it's not going to affect so much the processing time in step one. 1600 and up should be fine for that. But if you had a really, really complex 3D model that you're ending up working or looking at the end, or a very complex point cloud, when you're actually actively manipulating that in Pix4D, the video card will impact performance there too. So if you end up having that feel sluggish or laggy, it could be that the video card is not keeping up there, and you might want to get a higher end one. That's something that I would like to measure at some point in the future, but it's really tricky to measure subjective responsiveness like that compared to just measuring the amount of time something takes to process. So at the moment, that's not something we directly tackle, but just be aware that is impacted by the video card. Do we know when the new Ryzen series will be available? So the Ryzen chips, the 3000 series, like the 3950X and 3900X, are available now. They're in shortage a lot of places, certainly, but we've got them on our systems, and I've seen them on Newegg and Amazon. I don't know if they're currently in stock. The Threadripper models, the similar ones, the 3000 series, were just released a couple weeks ago. And again, they are also out there now. We are just wrapping up our qualification on them internally. The CPUs are fine, but we had to find motherboards that fit our cases and had all the features we wanted and things like that. So we should be adding those on our website in the next week or two, maybe. I don't think it certainly should be before the end of the year. And I know I'm excited to be able to offer those here. Let's see. Have you tried PCIe Gen 4 SSDs? I have not personally. We have qualified some for use in our systems because I didn't really touch on that. Honestly, SSDs of almost any type of quality, at least, are going to be fine performance-wise for Pix4D. It's not moving around that much data that PCI Express Gen 3 or 4 makes a huge difference. But they do exist. The new Ryzen and Threadripper 3rd Gen stuff supports. They're the first platforms actually to support PCI Express Gen 4. And so we do have some SSDs qualified for use with those. Again, I don't have any personal experience with them, and it's just really a theoretical bandwidth increase. But I mean, you're talking going from like 1.5 or 2 gigabytes a second to 3 or 4, I believe, if I'm remembering correctly. And you're already talking about just tremendous amounts of speed with any of those high-end SSDs. I don't really think it'll impact Pix4D. Let's see. Are there any other hardware recommendations for running multiple jobs at the same time? That's actually something someone only brought up recently. I'd never really considered before. My thoughts on it at sort of first blush are that Pix4D uses hardware well enough. I don't think I would run multiple jobs at the same time. I think it's sort of weird. So in step one, yeah, there's certainly a lot of extra CPU available to do other things if you wanted. It's really not using all the cores. But once you hit steps 2 and 3, Pix4D will try and use pretty much everything you've got. So if you're splitting that between 2 different projects, you're talking about doubling the amount of memory that you're going to need. So that's something, I guess, to consider hardware-wise if you really wanted to do that, is each project is going to need its own section of RAM. And at least with the sort of CPUs we're talking about here, like workstation class CPUs, the Core series, Ryzen, Threadripper, those peak out between 128 and 256 gigs of RAM usually, which is fine for almost any single project you could do in Pix4D. But if you're talking 2, 3, or 4 projects at a time, You could easily need a lot more than that, and that usually means having to move up to a server grade processor. So something in Intel's Xeon line or AMD's EPYC line. And they're very similar. A lot of the Xeons use the same technology the Core X series does. Anything that's a Xeon W, well, not anything, they have some other models now, but so you can kind of get an idea if you figure out what generation the Xeon and EPYC stuff is based on, how it will perform by looking at the workstation parts. But they do support more RAM by virtue of supporting a specific type of RAM called ECC registered memory. That's something that usually is only on Xeon and EPYC chips, but you can get those in higher capacity modules than you can with normal memory. So that's the only thing that comes to my mind. But again, I would, unless you do a lot of testing on that on your own, I would really hesitate and probably just stick with one project at a time because of how well Pix4D will use the system in steps 2 and 3. Yeah, I think that's kind of the best I can offer there at the moment. My benchmarks, unfortunately, won't work with multiple instances of Pix4D running. So it's not something I can easily test. Are the RAM timings and speed influencing performance? A little bit, and more so on AMD chips than on Intel. Intel chips tend not to care a whole lot, very, very tiny, a percent or two difference between different memory speeds. AMD is much more sensitive to that, and we actually have, I think our article from when the Ryzen 3950X launched looks at a couple different memory speeds and shows the performance gain. But something to keep in mind, you can buy memory that's rated at ridiculously high speeds, but CPU manufacturers, particularly AMD, have very specific speed ranges that they say their CPUs officially support. And anything beyond that is sort of overclocking. The memory controller is part of the CPU, and if you're running it at a higher clock speed in order to work with higher speed memory than it's rated for, that technically is overclocking and can technically void warranties and things like that. So we don't really mess with that here, but that is something on the AMD side. You will see a several percent swing depending on the speed of memory you're using. But I would caution not to go too high, because if it's 5% faster, but every once in a while the whole system crashes and you lose all your progress on a project, you've wasted all that speed benefit. So what I would do is just stick with AMD's recommendations or official support guidelines, which I believe for both 3rd gen Ryzen and Threadripper are, if you are using one memory module per channel, they can go up to 3200 megahertz. If you're using 2 memory modules per channel, if they are single rank memory, you can do 2933 megahertz. And if it's dual rank memory, you can do 2666 megahertz. That's their official specs. Most likely anything in that 2600 to 3200 range should be okay most of the time. But again, I would stick with their specs. Going above 3200 might benefit you a little bit, but to me, the trade-offs are too risky. Oh, and timings you also asked about. That will have some impact too, but much less from what I've seen. Timings is how many cycles memory takes to get data accessed, how many clock cycles. And it's usually, again, a very tiny difference there between different memory modules. I would personally put getting high quality, a good brand of memory as more important for reliability than trying to eke out the best timings. Let's see, Pix4D React needs 32 gigabytes. Honestly, Pix4D React is new enough. I haven't played around with it at all yet. And so I'm not entirely sure what differences it has compared to like Pix4D Mapper, which is more what I tend to focus on. My impression from looking at it is I think it focuses more on just the mapping side without so much of the 3D modeling. So I'm not sure. I guess I would recommend reaching out to the folks at Pix4D and talking to them directly. They're going to be more knowledgeable about that. If it's something a lot of people have interest in, I can see about getting a license for it. We don't have one right now. We just have the licenses for Pix4D Mapper. But I could take a look at that. But my impression is it's designed to be lighter weight and more narrowly focused, specifically to getting quick results, like on scene in an emergency situation or something. And again, more of a focus on just mapping rather than some of the additional stuff that Pix4D can do, more complex stuff. So yeah, I unfortunately don't have a specific answer for you there. I'm sorry. Let's see. It looks like that's all the questions. So, oh, does Pix4D Mapper need minimum 32 gigs to start working? No, you can do less. That's just kind of our general recommendation. If you had a really small project, like something in the 100, maybe 200 image range, you might be fine with 16 gigs. The thing to keep in mind is the actual system itself, the operating system, is going to use a few gigabytes on its own. And then Pix4D, just by virtue of running, uses a little bit. And any other applications you have open at the same time use some. So 16 gigabytes of system memory really probably only means like 10 to 12 that Pix4D can actually use for working on a project. Whereas 32 gigs probably means like, what, 24 to 26 available for Pix4D to actually use on a project. So there's quite a big difference there. It's not doubling the memory in the whole system more than doubles the amount Pix4D will have available to work on a project with. So I would only go with 16 gigs if you're definitely working with very small projects by comparison. The stuff that we're testing with here on the large side anyway is many hundreds of images, and I definitely wouldn't want to be on 16 gigs with that many. But as I mentioned, what you can actually do, I don't have a good way to demonstrate it here, but you can use Task Manager while Pix4D is running to monitor system memory usage. And then you can also look back at the log file after it's done and see. And that way you can tell if you got 16 gigs and you're routinely hitting 90+% memory usage, 16 is probably not enough. It's probably starting to use swap space and slowing down performance. So I would just take a look at that, but it certainly will run with 16. You just might get really poor performance with medium to large projects. Quad channel versus dual channel memory. That really doesn't impact. It's kind of a weird way to put. Okay, so what he's asking about there is CPUs support different amounts of memory and specifically have different amounts of bandwidth available to talk to the memory, and that's described using channels. So for example, the mainstream Core series from Intel and the Ryzen series have what's called dual channel memory. There's two memory controllers in the CPU. They each can talk to memory separately, and so you get basically double the performance you'd have if there was only one memory controller in the CPU in terms of the bandwidth between the CPU and the memory. You move up to the higher end, like the Core X series or the Threadripper series, they have quad channel memory. And the reason they do that is because you've got more cores, usually on those higher end processors. Like, for example, Threadripper's 24 and 32 cores versus 16 and lower on Ryzen. And to keep data fed constantly to those cores so that they can be processing, it needs more bandwidth available to talk to the memory. Otherwise, you could have more cores, but they're sitting there not doing anything because the memory path between the CPU and the RAM is already saturated and it can't get more data for those other CPU cores to work on. So yes, if you took a Threadripper and for some reason only populated half the memory channels, you would suffer performance-wise compared to having all 4 channels populated. But going over to Ryzen, it's not like if they just added memory channels to a Ryzen processor, it would suddenly be better. Dual channel is enough to keep all 16 cores fed with data. You go up to more cores, you need more memory channels to keep all those extra cores fed with data and able to process. So yes, quad channel is better on a CPU that supports it. You always want to have all the memory channels populated on a CPU, basically. I guess I could have covered that in the RAM section. I'm sorry, that's basic enough. I wasn't thinking about it. But yeah, definitely worth keeping all of the memory channels you have available populated, but I wouldn't buy a higher end processor just because it had more memory channels. Look at actual real world performance. Let's see, if you bought a Puget system with a 7th gen 30 core i9 with 64 gigs of RAM, where does it start to become feasible to consider an upgrade for 10th gen or wait for a few more generations? That's a good question. One of the other guys here actually did a series a while back looking at older system performance. Maybe I need to do something like that at some point, because what we usually end up doing is only testing the most recent generation or two at any given time. So it's hard to know exactly how much of a performance degradation there is going back. But the 7th gen Core series processors were, I'm trying to remember how many cores those had. I think you'd probably already be at the point where moving to something newer could offer a pretty sizable upgrade in performance, especially if you want to stick with Intel, you can. But these the new Ryzen chips and Threadrippers, if they're in your budget, are fast enough that I would wager you're probably already looking at 20, 30, maybe 40% increase in performance. Like we saw with the customer data set where he'd run it on a dual Xeon system from a few years ago. That was like 100% performance increase or even more, doubling performance. You're not going to be looking at that much of a difference with a 7th gen core processor, but you're probably looking at, I'd say, 30, 40% increase, something in that ballpark in performance with a newer processor, again, especially the AMD ones. And I haven't encountered any issues with those AMD ones myself. We had some weird quirks with AMD on the 2nd gen Threadrippers, just some strange behavior. But I haven't seen anything with the new 3rd gen stuff. It seems to be pretty solid to me. And again, I'm sort of testing in an isolated environment up here, one motherboard, one set of hardware. So our product qualification guys who deal with multiple motherboards and figuring out what the best and most reliable is might be better able to address that. But to me, it seems just fine. How should I decide between getting more RAM versus a better graphics card? With the RAM thing, I would take a look at how much RAM is actually being used. Look at the log file or look at Task Manager while it's running and see. If you're not using, if you're using less than 80% of system memory at peak, like in your biggest project, at the most intensive point in its processing, if it's using less than 80% of your system memory, then you're probably just fine. There's no need. I don't know exactly where Windows draws the line and starts to move stuff over to the page file, but certainly if you're below 80%, you should be fine. And so if that's the case, then you don't need more RAM, but you might also not benefit from a better video card. I wouldn't, if you're on a video card from the current 20 series or the previous 10 series and at least like a 6 gig card or higher, I probably wouldn't bother upgrading for Pix4D. I don't think you'd really see much. If you're on a much older card or a card with a lot lower memory, might be worth doing, but I would probably encourage getting it from somewhere where you could return it if it turns out it doesn't benefit performance. Yeah, 1066 gig should probably be just fine. Again, unless you're working with really large projects and it feels sluggish when you're looking at the finished model or the point cloud. But in terms of just raw performance in Pix4D when processing, that should be fine. Yeah, and that's the navigating through the project. That's the part where I don't have good performance metrics on that because it's kind of a subjective thing. It's hard to measure that in any reliable way. But the 1660 Ti should be a solid card. Really anything 1600 or above ought to be just fine in my experience. So hopefully that helps. And if you do have other questions, it looks like that was the end of the questions here for now. But if anyone does have other questions, you can feel free to go to our articles and comment there. I try to peruse those comments and answer them and interact there. You can also, if you're looking for a system or have questions about configurations, feel free to call or email us. We've actually got, just here as a final slide, you can see there how to get again to our recommended systems for Pix4D, which also have links to articles and things. There's also a shortcut URL over there, just pugetsystems.com/go/Pix4D. We'll get you straight to that page, and then our phone and email contact information if you do want to reach out to us further. So thank you everyone for watching. I hope this was helpful. And yeah, if you have a chance, there should be a feedback option, I think, here at the end as well when the webinar is over. We'd love to hear what you thought, if you have any comments or insight. And yes, last question there. Yeah, we will have this available. It'll take a little while to process, but we'll get it back up on the website to where you can view it after the fact or share it with others. Yeah. So thank you very much. We'll sign off now. Have a great rest of your day.